Hello. In response to some of the recent global events regarding, to put it simply, human rights and justice, I wanted to frame the conversation using a little bit of math terminology because I think sometimes some plain logic and math language can help us to step back and understand things slightly differently. So I've pulled up this Math is Fun website and just gone through some common symbols in set theory. And so you guys can look at this on your own if you like. Set theory might seem like mathematical terminology and mathematical representation, might seem like kind of wonky terms that don't have any real world application. And maybe that's why a lot of us don't like mathematics, is because we don't see any real world application. It doesn't seem relevant, but there are underlying logics and there is a mental archetype, so to speak, within mathematics that can actually be very useful even in artistic and emotional and psychological and human interactions. And so I'm going to say here that the universal set U, the set of all possible values, I'm going to call that all people. So that's 7 point some billion people in the world today. And each individual, you and I and all of your friends and family and everybody you go to school with and everybody you see on television, each of those bodies, each of those people is an element, a single placeholder in the set of you. And elements look like this. They could be numbers, they could be letters, they could be strings, they could be variables. It's an element of you. So U contains all people, and all the elements are the people. And then we can take those individual people and we can categorize and classify them in many ways. Right? So we all have nationalities, we live in certain cities, we have different hair color, we have different heights. All of these are categories and classifications. And we can then say U has many subsets. Chinese people are a subset, German people are a subset, Congolese people are a subset, and each of those subsets can be broken down. Each of those subsets contains discrete elements. Discrete just means unique, right? Alone or unique. So each person is a discrete element of this universal set U. And they are also discrete elements of subsets like nationality or race or socioeconomic status or something like that. And then even each individual person, if you're into psychiatry or even other medical sciences or physical sciences, each person has descriptive characteristics and traits of a biological or physical or emotional or psychological or other nature. And we could consider each of those an element. Some people are happy, some people are sad generally, some people are funny, some people are X, Y, and Z, different things, right? So we could use even the individual person as a set, which is a subset of all people U. So again, using set notation, let's say that A, big A, is a subset of U. Okay, so this is a group of people in the whole population. And let's just say, for example, it's a general demographic category like gender, and male and female, or if you think etc., put that on there. So we're going to say A contains these elements, right? If there are 25 of them in your world, that's fine with me. Typically, we're dealing with M and F. B is also a subset of U, right? So B is another category or characteristic in the universal set, right, of all people, right? And so let's say that's another demographic category like race, and we could have Latin or black or East Asian or white or whatever. We could break down races into more than 5 or 6 categories, you know. And then we also have C and D. You know, it could be family income status, it could be high school or other education, and so on and so on. We could break people up into categories and classify them for social scientific research or any number of different demographic, political science purposes, right? And so we're going to say, therefore, universal set is the superset, means it contains all the values right? It contains all the values within X, big X. We say big X is a subset of U, right? Big X is contained within U. So the universal set has all of these different subsets, and all of those different subsets are in U. There exists no universal set such that small x, which is an individual, is not within U, is not contained in U, nor big X, that's the subset of U, such that the universal set does not contain that subset, or else we have an empty set, else empty set. For each individual small x, that small x is contained within the universal set. We're all part of the whole population. And small x is contained within various other subsets. So we're all part of the human population, and we are also all part of individual distinct groups that we identify with, or that we were born into, or that we work within, or that we choose to be in, or whatever, whether it's physical, biological, social, or other subsets, right? So for all small x, these are the individuals in U, the universal population, the union of this individual and all other individuals, or the complement, the union of this discrete variable at a base level, at a smaller level, and its complement. The complement means everything that is not this person. So the union, which is like the sum of U and all the people who are not U, equals the universal set, or the whole world population. That's pretty simple sounding, right? And so we could also say the intersection of some individual, small x, and some other individual, small y, right? The intersection of small x, small y, small a, any number, we could have thousands of small letters, and the intersection of some individual and some other individual is where we form those subsets of the whole population. So you share a hair color with this other person. Now you are in that subset. You have the same education as some other people, and so now you are in that subset with those other people. That would be the intersection, the things you have in common. So x, let's say x is an element of A, and we're going to say x is female. X is the element in this subset of U, which was gender, and we're going to say that's female. So x is now a female in the element in the subset A. X can then be broken down into further subsets. Well, females come in many different varieties. They have different distinct characteristics. Some are tall, some are short, some have brown hair, some have blue eyes, etc., etc., etc. And those same subsets could also be framed as sets with other elements. Well, tall people, we could split this out into a tree diagram, which could then be split out further into more branches on a tree diagram. Tall people come in many varieties, right? Short people come in many varieties, and so on. If T, moving along, if T is the set of all tall people, that's the first element in our the set that we made out of the element female, right? So X is female, X is an element of A, and now we took X and we made that into a subset or a set, and now tall is an element of that set, and we're breaking that down into further subsets, branching out the tree diagram. Okay, so T, big T, is the set of all tall people. And then T includes men and women and Arabs and poor people and happy people and engineers and surfers and people with long hair and any number of different tall people. The one thing they share in common is the tall people, that they're tall. So no matter what this person is, this X up here, say that's men, so this small x is men, and that other one is happy people. And in this case, what we're looking at is their intersection on the basis of their being tall. Right, and that's where we form that set. It includes many different people. T complement, or the opposite, or not T, includes all people who are not tall. It doesn't mean they're short necessarily, but they're not tall, which again is a wide range of individuals who fall into many subsets of the whole population. So there exists T. There exists T contained within the universal population such that T is in A, oops, T is in A and T is in B. So again, there exists something in the whole population such that that thing or that characteristic or that variable is in this subset and it's also in this subset, and so on. But if X is a person in T, there exists no such X in T complement, right? So if X is a person in T, right, so if you're tall, there exists no you in short, right? If you are tall, you are not in not tall category. If you're in a category, you're not in the category which is not that thing, because a tall person can't be both tall and not tall at the same time. Therefore, there exists X in U, right? So there's a person in the whole population of the world, right? Or of a more limited population, but U is the whole population in our example here. There exists a person in the world such that that person is in some group, and that person is in another group, and that person is also in another group. People are more than one thing, right? They belong to many groups, and so on. For example, if X is a woman with brown hair, right? So X is a woman with brown hair, right? So she's in this group, and she's in this group. She's already in two groups. She could be a Chinese woman. There's a third group with a bachelor's degree. There's a fourth group from a family with middle income level. That's a fifth group. And we could go on and on and on down to the base of her individual DNA sequence, right? In which case there would be only one of her and all others would be X complement. X could also be a black woman from a high income family holding a professional degree. So we've got black, that's one category, woman, there's another, high income family, there's another, holding a professional degree, there's still another. People are more than one thing, they belong to more than one group. And these groups have crossover. So for all big X, those are the subsets in U, for all big X in U, right, there exists further subsets in each big X, right? So for all those subsets, for all those, up here we had gender and socioeconomic status and education. In this group, Latino or Latina, there exists many other subgroups. Among bachelor's degree holders, there exist bachelor's degrees in science and arts and various other disciplines, right? Down to very specific, precise categories or elements, right? And so, for example, I have a taxonomy chart over here. There exists X in A, the animal kingdom. Right, so here we got bacteria, plants, fungi, and then animals. Here is our animal kingdom. And we also have things like class and phylum and other levels here, right? And so there exists X in A such that X is in F, F is fish, and X is not in M, which is mammals. All right, so if we say that X is a fish, if the distinct element we're talking about is a fish, then that fish is in the larger set of animals. That fish is not in the other subset, mammals, right? Mammals are also in that larger set of animals, right? Which fall into living things, an even larger set, right? But fish and mammals on down the tree diagram are too distinct to be compared to one another. There also exists P in M. We're going to say P is primates. P in M. M is mammals. So there exists primates in the mammals set, or subset, of the animal kingdom, such that X, a more precise species, is in P, and Y is in P. So X could be humans, the Homo sapiens species, and some other species of monkeys. Well, those are both mammals, and they're both primates, but they're not the same. Right? So in summary, well, each individual has distinct DNA sequence down to a very precise level where an element is very distinct. Even some of those sequences in our DNA are shared by other humans and even other species, right? So all across the spectrum of living things, we all share commonalities. People share common traits with one another. You can find people in all of these different groups of races and education and income level and religion and so on that share probably more commonalities than differences. And a person can exist in multiple subgroups, right? Just because you are a white, middle-class, college graduate male from a middle income, or I said middle income family, going to church on Sunday doesn't mean that you automatically identify with the politics of other people in your same group. Similarly, just because you are in some other group doesn't mean you identify with the politics or X, Y, and Z things from that group. You can cross over, right? We share some characteristics and then we diverge in other areas. And there's no universal rule because, as we can see from this simple one-page explanation, this gets very complicated with a web work of tree diagrams that would best be represented in 3 or more dimensions. So a person can exist in multiple subgroups, and then people from other subgroups who may appear to share no commonalities can actually appear in some of the subgroups with others very much unlike them on many, many different levels. So members of one subset can exist in subset with members of seemingly very different subsets. Even very dissimilar people have certain commonalities, while at the same time identical twins whose DNA is identical. They're not in union across all criteria. Identical twins could have different educations. They could have very different preferences in music. They could have different X, Y, and Z, right? One might like pizza and the other one doesn't. One, it doesn't have to be trivial, but down to a trivial level, we are not exactly the same, even if our DNA is exactly the same. Therefore, no matter how different you think you are, you share traits with others, psychologically, socially, economically, religious, physically, and otherwise. And no matter how similar you feel to others, there are mental, physical, and spiritual structures that dissect the whole of the human population. And so, thank you. I hope that was not too confusing. But as with many different things in life, math can be used to explain things to a math-literate audience anyway. Even where sometimes it seems like math is irrelevant. Math is in every aspect of life, as Elmo said bravely, proudly, and many times on Sesame Street, math is everywhere. And indeed it is. Thank you.